Check it.
Okay, so today we're starting lesson 5-7. It's projectile motion and also finding vertex form. Now, we already learned how to put an equation to vertex form in chapter 2. Just a little refresher here. Let's say that you're doing a graph and I give you an equation like y equals 2 times x minus 7 squared plus 5. You guys hopefully remember that this meant you're going to take your parabola. Your parent function is a parabola here, right? And this is telling you to go which way? This is going 7 to the what? 7 to the right. This is telling you to go which way? 5 up. And what was this number here? This was called the what? The dilation, right? And if the dilation number is positive, the parabola is opening upwards. And if the dilation is negative, it's opening downwards, right? So this is stuff we already know. What's great about vertex form, and the reason why it's called vertex form, is that you can tell what the vertex of the parabola is just by looking at this, right? The vertex, if you remember the formula, was y equals a times x minus h squared plus k. The vertex is simply whatever h is, comma, whatever k is. It's h comma k. So that's what's great about vertex form. Now, if I ask you to graph something that's in standard form, you don't have the ability to know what the vertex is, right? Like, let's take a look at this equation right here, number 16. Okay? If you look at that, what can you tell from that? Because that's a parabola as well. But that's in standard form. What's standard form? Standard form is y equals ax squared plus bx plus c, right? So you can see there's an a, you can see there's a b, you can see there's a c. But can you tell what the vertex of that parabola is? No, you can't. What's the only thing you can tell by looking at that? The what? Y-intercept. Yeah, if you put in a 0 for x, you can find the y-intercept, right? So that's about it. You can't find anything else by just looking at it. You'd have to do a significant amount of work. Like, for instance, if you wanted to find the x-intercepts, you could factor it, set y equals 0, factor your 0 product rule. But in terms of finding the vertex, you don't have a way to find the vertex. So let me show you a way that you can find the vertex and actually change this from standard form into vertex form. Because once you have the vertex, the truth is you have everything. Now, vertex form, once again, is y equals a times x minus h squared plus k. Now you notice both forms, standard form above, vertex form below, they both have an a. You see that? Yeah. It's the same a. There's no coincidence that both are lowercase a. They're the same number. So if you're doing, if you're trying to figure out what is the, you need to figure out 3 things to do vertex form. You need the a, you need the h, you need the k. The a is a freebie because the a is, you can just copy it. Okay? You can just take the a. So what's the a in this case? It's 1, right? So doing vertex form for this, you already know a is 1. So I can erase the a because, you have to write if it's a 1, right? Okay. The question is what's h and what's k, i.e. what is the vertex? Okay? So here's the thing. If you look at any parabola, okay, here's a little graph. And I don't know, I'll just draw a parabola here. Its vertex is h comma k. But a parabola is a symmetrical object. It has what's called an axis of symmetry. How many of you guys remember the term axis of symmetry from geometry? Okay? It's a line, a vertical line, that has an equation, x equals something. Okay? Vertical lines have the equation x equals. Horizontal lines have an equation y equals something, right? So the question is, what is the number here? What is the h, okay, that's going to equal? Because if you look at it, the axis of symmetry passes vertically down through the vertex, right? So if you know that a vertex is h comma k, this line, this red dotted line called the axis of symmetry, it has to be x equals whatever h is. So how do you find what the h is? Well, there's a nice little formula that we can use, okay? Now, let me just show you something here. This is the quadratic formula right here, okay? And we already learned that this part of the quadratic formula right over here is called the what? That's the discriminant. So there's an important thing within the quadratic formula that we use. Well, guess what? This part of the quadratic formula right here, or actually more to the point, this right here, this is the formula that we want. So the formula I'm about to show you is actually also part of the quadratic formula. It's the other part, okay? It's x equals negative b over 2a, all right? But it's a little different than the way it's written here. It's x equals a negative, then a fraction that is b over 2a, all right? But an easy way to remember it is just, it's the other part of the quadratic formula, okay? So that's a nice way to remember that. Now, the reason why I say it this way is because the negative is not part of the b. The b might have its own negative, is what I'm trying to say. Okay, and if you know what this is, then now you know what the h is. Okay, so what's my b in number 16? It's negative 4. So x equals negative b over 2a. Notice I don't say negative b over 2a. It's negative b over 2a. Negative, and then what's my b again? It's negative 4. So the b has its own negative. It's a separate negative. I don't want you guys to conflate those two. They're not the same one. And then you have times 2a. What's my a in this case? It's 1. So let's simplify that. That's negative negative 4, which is positive 4 over 2. This is positive 2. So what is the equation of my axis of symmetry? 2. Okay? The equation of the axis of symmetry. What do I mean? So if I say, what's the axis of symmetry? You just say the number 2. You're not going to get credit for that. It's an equation of a line, like y equals mx plus b. In this case, it's x equals 2. So the axis of symmetry, I'll just write it as AOS because it's a lot of writing, is x equals 2. That's our axis of symmetry. That means that this is 2 here. And what is my vertex so far? It's 2 comma k. Now, how do I find the k? Well, if you have the x coordinate of the vertex, how do you find the y coordinate of the vertex? Just plug it back into the equation, right? So take a 2, plug it in here. What does this become? This becomes 2 squared, which is what? 4. Yeah, I'll do this in green over here. This is 4 minus 4 times 2, which is what? 8 plus 9. 4 minus 8 is negative 4. Negative 4 plus 9 is what? 5. So there you go. It's going to be, the vertex is 2 comma 5. And that's how you find the vertex and the axis of symmetry. You have to find both of those things. Now, once I have 2 comma 5, what can I do with vertex form over here? Back over here now. This h is what? 2. And this k, the vertical shift, is 5. And there you go. Now you have it in vertex form like we did in chapter 2. So that was the first thing I wanted to show you. How do you take a standard form equation, which is number 16, use that little baby quadratic formula, negative b over 2a, use that to find the axis of symmetry, right? And then once you find out the axis of symmetry, you've got the x. Now you just have to find the y, and that gives you the h and the k. Okay? And of course, you also need an a, but we said a was 1, so you basically just take the a from, what do you call it? You take the a from the standard form and you use it in your vertex form. Let's try one more, and then we'll go on to something else today. So 17 is in standard form, right? And I want to know what's its vertex. Okay? So the first thing I'm going to do is go ahead and use x equals negative b over 2a. That'll give me the axis of symmetry, okay? And by the way, we're also going to do a quick graph of this while we're at it. All right, so what's my b? Negative b is negative 24. Okay, the b had its own negative, over 2 times a, and what's my a? Negative 4. So I have negative 24, which is, oh, sorry, 3 negatives actually, right? I have a negative here, negative here, negative here. 3 negatives give you a negative, right? So negative, and then 24 over 8 is what? 3. So what's my axis of symmetry? My axis of symmetry is x equals negative 3. All right, so we have the h, okay? So what does that mean? Let's start drawing our little sketch here. Okay, we have our axis of symmetry, which is the vertical line x equals negative 3. Remember, x equals means it's a vertical line. So you're going to draw it as a dotted line on your graph. Just like you did with the parent function before it was dotted. Well, the axis of symmetry is a dotted line, vertical line. Now, what does this tell us? This tells us that our parabola is centered on that axis of symmetry. It's not over here. It's not over here. It's not over here. It's not over here, right? It's got to be on this line here, somewhere on this line. And if it's upside down, it's going to look like that. But it's on that center line. Okay, that's the important thing. And by the way, what's the a here? Negative 4. So this is actually going to be upside down and down. Okay, what do we know, by the way, from standard form? We know what? The y-intercept is obvious. It's negative 15. It's way down here somewhere. So my graph is going to be, is not even going to fit on this graph. Like it's totally out of scale, but it's okay. It's fine. That's the axis of symmetry. But what is the actual like vertex now? Well, to find the rest of the vertex, I need to do what? Right, this is the x. I need to plug it in here to find the y. So why don't you guys go ahead, use your calculator, tell me what my y is, and then tell me what my vertex is. All right, so what do we get for our y here? Let me hear it.
21.
You guys all get 21? Positive? All right, so the vertex is 3, 21. Now we can write vertex form. What is the vertex form of this parabola? Y equals, well, a, right, is what? -4. You can shoplift it from the standard form. It's the same a, right, times x minus what? -3. So it's not x minus 3, it's x plus 3. X minus negative will be x plus squared. And then what's the k?
21.
Plus 21. There you go. That's a vertex form. So if I ask you to just change something to vertex form, and I will tonight on the homework, that's what you're going to do for that. Now, for graphing, now that you know the vertex is -3, 21, this thing is dilated, isn't it? The A is not 1, yes?
Yeah.
What happens when it's dilated? You must make a what? A table, right? So the table will be centered at what x? -3. And that means you need to go 2 to the right and 2 to the left to get a decent graph. What would be the two x's on the left here? -4 and -5. And the 2 on the right? -2 and -1. Now we already know that this one's 21, right?
Yeah.
And we also know that it's going to be 0, -15 because that's kind of a freebie, right? The y-intercept is 15. So if you wanted to make a graph now, all you have to do is fill in these x values, right? Fill in this one here, 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 and you would have your graph. I'm not going to bother doing that right now because you guys know how to do that already. But what I wanted to point out is by finding the vertex, you now have the center of your table. Okay? Whereas before, you relied on vertex form to tell you where your table is going to be. Now you use x equals -b over 2a to tell you where the center of your table is going to be. Okay, you guys, does that make sense? All right. So this axis of symmetry, it tells you what your table is going to be. It also lets you find the x and the y that is your vertex. It's very, very useful. And it's basically part of the quadratic formula, in case you forget where it is. All right, so the second thing we're going to talk about here is projectile motion. All right, so projectile motion, you guys might have seen in physics. If you fire a gun, for instance, that's called a projectile, right? Or if you shoot a bow and arrow, or an arrow with a bow. Or if you throw a ball. Those are all projectiles, right? Now, it may seem to you like when you shoot a bullet that the bullet goes straight, but it doesn't, okay? The bullet is following the same path as if you threw a ball, which is, here's an eraser. I'm going to throw the eraser across the room, follow the eraser across the room. What shape does this make? It's an upside down parabola. It is not like an upside down parabola. It's literally an upside down parabola, okay? When you throw something, it acts in a parabolic fashion. And it's so literally a parabola that you can find an equation that will totally perfectly model that trajectory. And if you know the equation of the parabola, you can tell all kinds of things like, what's the highest point? How long did it take to get to the highest point? When does it hit the ground? That sort of thing, okay? Where is it at any given second? Because you can just plug in a second at any moment in time and see what the height is at that moment, and the distance as well. So projectile motion, and by the way, a bullet or an arrow, let's say I had a bow and arrow and I had, a target that was exactly at the same height as me, right? Like, let's say my arm here is at 5 feet, right? So the target is exactly 5 feet off the ground, straight that way, 50 feet, let's say. If I were to shoot the arrow straight at it, what would happen? It wouldn't hit the target. It would what? Hit the ground because of gravity, right? So what do you do to make up for it? You bow up a little bit, right? And what are you creating? You're creating an upside down parabola that goes up, has a vertex, comes down, right? Same thing with a bullet, just on a longer scale because the bullet's moving faster. It takes longer for it to go up and come down, but it does the same exact thing. So finding a projectile's path. Now the main two things that you're going to have to focus on when you're dealing with projectile motion, okay, is the main two types of questions you'll be asked is, how high did the projectile go? What's the high point? Okay. Now, if you're talking about a parabola, where would the high point be? It's going to be at the vertex. So really what you're asking, what they're asking you to do is to find the vertex of the parabola. The second thing is, where does it hit the ground? Well, what are you looking for in terms of? Yeah, the x-intercept where y equals 0, the height equals 0, and that means it's on the ground. So it's very, very simple. If you're asked to find the high point, you're going to change the function into vertex form, or at least find the vertex. And if you're asked to find where the projectile hits the ground, you're going to find the x-intercepts of that parabola. Okay? Every parabola has a maximum and a minimum. Let me go back to the parabolas for a moment here. There's one thing I was going to talk about which I left out, so let me go back to it, which is, look at this parabola right here. Every parabola has either a maximum value or a minimum value. Okay? Which does this parabola here have? Okay? This parabola goes up forever. It never stops going up. It has no top, but it does have a bottom. You agree with that? If a parabola has a bottom, it has a minimum. What's the minimum value of this parabola? This parabola has a minimum value of? 2. Y equals what? 5. Okay? This right here is a 5, and this right here is a 2. I know it's not to scale, okay? But that is the coordinates 2, 5 for the vertex, right? So if you know the vertex, you know the minimum. Now, what's the maximum value of this parabola? It doesn't have one. Okay? There is no maximum value because it goes up to infinity. Infinity is not a number you can actually quantify. So it has no maximum value. All right, what about this parabola over here? This one was 3, 21, which is ridiculously high, but I'll just fudge it and say this is 21 right here. So let's say the parabola is, it's actually over here, right? And it was going down from here. Remember, it was -4, right? So it's going down from there. Does this have a minimum or maximum value? This has a maximum value, so this has a max of what? Once again, don't give me a number, give me an equation. Y equals 21, because you do have people that will write x equals 21 because they don't understand what they're doing, right? It's y is 21, not x. X is -3, right? Okay, so yeah, the max value of y equals 21. Over here had a minimum value of y equals 5. Okay? All right, so now we understand maxes and mins. Max, and that's going to be part of the homework tonight. So what you're looking for when you do the highest point of a projectile's path is basically the maximum. All right, so let's do a couple of examples here. A rock is tossed from the top of a 1,000-foot tower. The height of the rock is given by h of t equals -16t squared plus 1,000. How long does it take for the rock to hit the ground? Which of those two situations is that? Finding the x-intercepts, right? Remember, it was either finding the vertex or finding the x-intercepts. This is asking you, where does a rock hit the ground? Now, it's a great idea to draw yourself a little diagram. So let's say this is the tower, okay? And we're throwing a rock off the tower, and it's going to hit the ground. And it will be a parabolic path, okay? And then here's the ground, okay? And the question is, where does it hit the ground? Now, this function is h of t, meaning this is h of t here, the height, and this is t, okay? And t is seconds, and h of t is feet, okay? And we're throwing the thing off the corner of the tower here. We're not throwing it up, we're just kind of rolling it off the top of the tower. And when does it hit the ground? Okay? Now this function will be different depending on the speed, because if you roll it off slowly, it'll probably just drop, it'll drop more straight than that, right? But if you put, a lot of force into it, it's going to create a parabola that's going to be either there or whatever, depending, like I said, difference between a ball and a bullet. So anyway, what's this t value here? At what t does it hit the ground? How long does it take? How many seconds? So we're looking for the x-intercepts here. So how do you find the x-intercept of any parabola? You make the y 0. Now in this case, our y is h of t, and what's our x? It's t, right? So this is, if you look at it in terms of x and y, it's y equals -16x squared plus 1,000, but let's use h and t because those are more appropriate for this problem. So you set h equal to 0, which makes sense, because if you set h equal to 0, you're saying that you're on the ground. If the height is 0, you're on the ground, right? So -16t squared plus 1,000 equals 0. And you want to solve that, and that will tell you when the rock is on the ground. Well, something weird is going to happen here. First of all, is there a GCF here? Yes, there is. It is what? Actually, it's 8. Okay? And actually, I'm going to make it -8 so that my factor in here has a positive t. So this will be 2t squared. And then what's 1,000 divided by 8? It's actually 125. So we get that. That's the greatest common factor. I can't pull out more than that. Now, you look at this thing and you go, can I factor this? Can I factor that? Is that a difference of squares? Really? Is 125 a perfect square? Go ahead. You have a calculator. You're supposed to have a calculator in this. What's the square root of 125? Is it a whole number or not? Or is it a decimal? No. So it's an irrational number. And also, I'll tell you what, 2 is not a perfect square either. So this is not a difference of squares. If it was 4t squared, yes. But 2t squared is not a perfect square, and 125 is not a perfect square. And the only way you can have a binomial, two things, and still factor it is if it's a difference of squares. Okay? For quadratics at least. So, and we already took out the GCF, so there's no chance of that. So yeah, this is not factorable anymore. So we have a factor times a factor equals 0. We can set each factor equal to 0 and solve now. -8 equals 0. Will that give us anything? No. 2t minus 25 equals 0. We can solve that algebraically. So here we go. 2t squared minus 125 equals 0. I'm going to add 125 to both sides. I get that, right? I'm going to divide both sides by 2. T squared equals 125 over 2. 62.5. Okay. And then what are we going to do after that? Square root both sides, right? What's the square root of t squared? Absolute value of t. And what is radical 62.5? 7.905. Now in this class, when you do stuff in decimal, and I'm doing this in decimal because it's a graph, you must go to 2 decimal places. So in this case, 7.905, you would round to 7.91. Okay, when you get to AP Calc, I'm going to make you go to 3 decimal places. But right now, for this class, 2 decimal places for most situations is good. Now, what happens with the absolute value? When you drop the absolute value, you t-bar this, what do you get? You're going to get plus and minus 7.9791, right? So you're going to get 2 answers. Now, does that make sense that there are 2 answers? Yes. It actually does, because if you think about it, this red parabola that I drew here, isn't there going to be another side to this parabola? But if I erase the rectangle, if this was the vertex, wouldn't there be another side? And once again, this is the y-axis here, right? Right there. So wouldn't there be, if this is 7.91, wouldn't there be a negative 7.91 on the other side? There is, but since we don't care about that side of the parabola, we're only interested in the positive side, we can drop the negative and say that it lands at 7.91 seconds. Okay? So that's how you take care of a hit in the ground situation. You find the x-intercepts. Now there are 2 x-intercepts, but only one of them is useful in the real world part of this situation. Now, I realize how unsymmetrical that looks, but that's okay. All right, let's try another example here. Example B. A ball is thrown up from ground level, so it's not on a tower this time. So the ground is going to be the x-axis, okay? And let's say this is the y-axis, okay? And the ball is going to be thrown up from ground level and come back and hit the ground at some point. And we want to know what's the maximum altitude of the ball. Well, what are we looking for this time? The vertex, somewhere around here. How do I figure out what the coordinates of that vertex are? We use the what? X equals negative b over 2a to find the what? The axis of symmetry. If we can find the axis of symmetry, that will give us the maximum value of the parabola because the vertex is on the axis of symmetry, right? So let's figure out where's the axis of symmetry for this. X equals negative b over 2a. So what does that give me? I have 2 negatives, which is a positive, and 60 over 32. What's that in decimal, people? What's 60 divided by 32, please? 1.875. Okay. It's not negative because there are 2 negatives there. Oh, sorry, that's not x, that's t, my bad. Well, it's x in the formula, but what we're finding here is t. So, yeah, in this case, it's a t for the purposes of this particular function. 1.875, so that's where you are. This is 1.875. But is that what we're looking for? No, that's the time that you hit the highest point. What is actually the height of the highest point? What is this value here? Yeah, so what do? Yeah, plug it back in, please, and tell me what is the maximum altitude of this ball. Okay, so somebody plug in 1.875 into negative 16t squared plus 60t. And what do we get? 56.25. Anybody get that? Yeah, that should be it. Okay, so the max height of the ball is y equals, or no, not y, h of t equals 56.25 feet. Okay, there you go. The path of a ball bouncing along can be modeled by y equals this function right there. Where is the horizontal position of the ball? Where x is the horizontal position of the ball and y is the height of the ball. What is the maximum height of the ball? So what you have here is a repeated kind of bounce. Okay? So you have a floor. Okay? And you're going to have a parabola where the ball, oops, if I can go through the origin here. The ball's going to, this is not exactly easy to do with one parabola. Okay, something like that. Okay? And then you're going to have, that's one bounce. Of course, just the part that's above the parabola, above the x-axis that you care about. But then the second bounce is going to be like that. And then the third bounce is going to be like that. So you're going to have, just follow the ball here. Boing, boing, boing. You follow me? Okay. And we're assuming that the ball is perfectly inflated and that it doesn't lose any height as it bounces, which is impossible in real life. Okay? There's some loss of energy in reality. This is an idealistic problem. So let's pretend we're in space and in space there's no gravity. We have gravity and no air resistance and nothing, no friction and no elasticity of the ball is lost or anything. So this is the situation here. What's the maximum height of the ball? Well, it would just be the height of one of these parabolas, right? So let's just find the height of one of the parabolas, the first one. And how do we do that? We just did it a minute ago. What do? X equals negative b over 2a. What's my b here? 2.5. And what's my a here? Negative 0.8. Now this is all decimals, and the policy in this class is don't create decimals unless you're given decimals. This is hella decimals, so go ahead, use your calculator and tell me what it is in decimal. Okay, what I'm getting is positive 15625. You getting that? Yes. Okay, so that's the x value of the axis of symmetry. That would be the center of the bounce. 15625. But what we want to do is to plug that in now and to figure out what the height would be at that moment. So what's the height at that moment? So plug that in and see what you get. Anybody else getting 1.953? Yeah. Okay. So 1.953125. You round it off to 1.95 because the next numbers are 3. Okay, so the maximum height of the ball is 1.95 feet. Okay, what is the horizontal distance between bounces? And now you see why I drew more than one bounce. Okay, the question now is how far apart are the bounces? Now, what would I use to figure that out? What they want to know is what's the distance from here to here to here to here, the distance between bounces. Like as it bounces on the floor, what are you looking for here? Yeah. Yes, the x-intercepts. If you knew the x-intercepts, you just look for the distance between the x-intercepts. So we need to find the x-intercepts of one of these parabolas, and basically the distance between them is what we want, right? So then once we find the x-intercepts, subtract the x values, and that'll give us the distance. Okay, so let's find the x-intercepts now. How do you find the x-intercepts of any parabola? You make y0 here, right? So what we want is negative 0.8x squared plus 2.5x equals 0. Now we want to put this in standard form because if you want to factor something, you want to put it in standard form. So I want to get rid of the decimals. What can I do to get rid of the decimals? Multiply everything by 10, right? If I multiply everything by 10, actually I'm going to do negative 10 so I can have a positive first term. That'll make this 8x squared minus 25 equals 0. So at least now it's cleaner, right? It's not as complicated looking. And now I look at it and go, is that something I can do, what do you call it, is that something I can have a GCF with? No GCF. Is that a difference of squares? No. So that means it's not factorable. I'm just going to have to solve it the way it is. So I'll add 25 to both sides. I get 8x squared equals 25. Divide both sides by 8. X squared equals 25 over 8. Then I need to square root both sides. So x is going to be the square root, well, absolute value of x will be the square root of 25 over 8. When I drop the absolute value bars, I get x equals plus or minus whatever this thing is, okay? So I'm going to put that into a calculator. The square root of 25 over 8, okay? So x equals 1.767766953, and plus and minus, right? So if that's the case, if one's plus and one's minus, what's the difference between them? Wouldn't it just be double that number? Yeah. So multiply that number by 2, and here's what I'm getting. I'm getting 3.535533906. So the distance between bounces, distance 3.54 feet. And I will box that as my answer. Okay? Their y-axis was actually here. Like that, okay? Their y-axis was actually through the vertex like that. So it was 1.76 this way and 1.76 this way. So there was a 1.76 in each direction. So you add them together, you get 3.53. And we're done. See you in the next video.
Check this.